Hello students, welcome to Target IES. I hope you are having wonderful day. Let us continue with today's revision module. In this module, I am going to finish 3 chapters. एक तो हो गया steel, aluminium and then timber. ठीक है? So steel, why we are studying about steel? Because obviously in construction industry, there is literally no industry without steel, right? So we have steel structures and concrete structures. In concrete structure also, to take tension, what we are using? We are using steel only na. So steel is very important, you know that. So steel का सबसे main element कौन सा है? Iron, right? From where we are getting this iron? Obviously we should get this from iron ores. We have to quarry the rocks which are rich in iron and we have to convert it into steel. Agreed or not? So let us see this process, what we are doing actually. So there could be a question, which iron mineral has the highest iron percentage? Like that a questions can come. So remember this, very important hai. So if you are taking magnetite, it is the richest in iron. So Fe3O4, it is richest in iron, 70 to 75%, followed by hematite, limonite, iron pyrite and siderite. Okay, याद रखोगे, at least remember top two, magnetite and hematite. Okay, so the first thing, whenever we are burning this, whenever we are burning this iron ores, first thing what we get is pig iron. फर्स्ट थिंग व्हाट वी गेट इज पिग आयरन. ए पिग आयरन क्या होता है? क्रूडेस्ट फॉर्म होता है. इट इज द क्रूडेस्ट फॉर्म. इट विल हैव इंप्यूरिटीज. ओके, इट इज द क्रूडेस्ट फॉर्म ऑफ आयरन, याद रख लो. एंड इट इज क्लासिफाइड एज बिसेमर पिग, फॉन्ड्री पिग, फोर्ज पिग एंड मॉटल्ड पिग. एंड हियर a important thing what you have to remember is color of this pig irons. Okay, color of this pig irons, foundry, forge and mottled. काफी इंपॉर्टेंट है, बिट्स पूछ सकते हैं, मे बी इन स्मॉल स्टेट पीएससीज, मे नॉट बी इन ईएससी लेवल, बट गेट में क्वेश्चन आ सकता है, नॉट गेट, इसरो में क्वेश्चन आ सकता है, राइट. सो बेसिकली हाउ टू रिमेंबर इज, ऑब्वियसली आयरन कौन से कलर में रहता है? बेसिकली इन व्हाइटिश कलर में रहता है ना. सो आयरन बेसिकली विल बी ग्रे और व्हाइटिश कलर or ash type color. So let us be very clear, we have white, we have gray. So see the last letter y. So foundry pig will be in gray color, forge pig e. forge pig कौन से कलर में रहता है? व्हाइट कलर में रहता है. सिंपल है ना. सो रिमेंबर दिस बिकॉज दिस क्वेश्चन वाज आस्क्ड. foundry pig was is in which color? So there will be 4 options given and you have to tick the right answer. So please be careful with it. foundry pig ग्रे पिग होता है, फॉर्ज पिग इज ऑल्सो कॉल्ड एज व्हाइट पिग. ओके, so foundry pig is gray pig, forge pig is also called as white pig and mottled pig is somewhere in between gray and white varieties. Okay, mottled pig is somewhere in between. And this, what is this Bessemer pig? See, the manufacturing of the steel, we use this Bessemer process. It is a very old process, 1850s se hai. So we have not it is so advanced. In 1850s only they started this Bessemer process. Even today we are using it. Okay, even today we are using it. And what is the favorite ore in which we will be going for steel? That will be hematite. याद रख लो, in Bessemer process basically we will be using which ore? Hematite ore. Okay, so this is about the pig iron. It is the very crudest form. So we are heating it to 1200 degrees centigrade and allowing it to be fused and we will be getting our pig iron. Okay, obviously it will have impurities. You can see the impurities. Carbon content सबसे ज्यादा रहता है. If carbon content is more, obviously what will happen? The brittleness will be more. So carbon content is almost 3 to 4% in this iron. Even though it is iron, it has certain impurities. 3 to 4% carbon है, 0.5 to 3.5% silicon है, 0.5 to 2% manganese है, 0.02 to 0.1% sulfur, and we also have small amount of phosphorus. Everything is clear, crystal clear. So now let us try to see what is happening, how to manufacture different things, whether it is a cast iron, wrought iron or mild steel. How to manufacture, let us try to understand. First we'll be taking iron ores. So here we have seen the iron ores. It could be the magnetite, hematite, limonite. Okay, so whatever type, we take the iron ore plus coke. Coke means nothing but carbon, plus limestone, plus our limestone, right? So you heat it at a very high temperature in a blast furnace. कितना तक है? यहाँ पे पॉइंट मैंने लिख चुका है. Pig iron is hard and brittle with fused temperature of 1200 degrees centigrade and melt easily. So we are heating to over 1000 degree centigrade, almost 1200 degree centigrade. हमको क्या मिल रहा है? Pig iron मिल रहा है. ठीक है. So this is the crudest form of iron. Crudest form of iron. So now what I am doing? I am again dividing it as per the requirement. If I am heating it in cupola at still higher temperature and I am remelting it and I am molding it in sand molds, then I will be getting my cast iron. What I will be getting? I will be getting cast iron. इसमें carbon content कितना है pig iron में? 3 to 4%, right? Here it was 3 to 4%. In cast iron generally it will be 2 to 3%. Carbon content थोड़ा कम था, ठीक है? So followed by next one, we have wrought iron. Wrought iron is very similar to that. Instead of burning in cupola, we will be burning in puddling furnace. Okay, what we are doing? First, we are smelting it. Then we are hammering it into layers. Then we are reheating it, and then it will be rolled into iron sheets, and we will be getting my wrought iron. No need to remember the process. Smelting रहता है, heat hammering रहता है, reheated रहता है, and then we are rolled, and we will be getting wrought iron. Here the carbon content will be less. It is the purest form. You can say wrought iron is purest form. You can see this point. Wrought iron is the purest form of iron, and the carbon content obviously I am saying it is the purest form. So carbon content क्या रहेगा? कम रहेगा. It is only 0.15%. Okay, so remember this carbon content. ये question काफी important है. ESE में भी पूछ सकता है. And then coming to mild steel, our favorite mild steel. See, obviously iron and steel में एक फर्क है. Steel is an alloy. Steel is what? Alloy. We are adding something more to the iron so that properties are improved. It could be chromium, it could be nickel, it could be tungsten, right? It could be manganese, right? Molybdenum. So whatever, we are adding something excess to that of iron. We are alloying it. So remember, we are smelting it, alloyed, rolled into our rods, and we will be getting mild steel. Okay, so we will be heating the pig iron in Bessener or open hot furnace. What we are doing, we are smelting it, and then it is alloyed, so the mineral composition is varied, and then it is rolled into bars. We will be getting my mild steel. I hope it is very clear. So remember, coming to cast iron, it is still having high percentage of our carbon. 2 to 4% तक रहता है, and it is very strong in compression. As it is high in carbon, obviously it is hard, but it is also brittle. It is also brittle. We need ductile materials in construction most preferably. इसलिए steel use करते हैं. Steel में क्या होता है? Carbon content काफी कम हो जाता है, ठीक है? That's why we will be using it. In construction industry, we will be generally using it steel, but not cast iron, because cast iron is having high percentage of carbon, and if we have high percentage of carbon, 2 to 4%, 2 to 3%, basically we will be having brittle nature. Done? याद रखोगे. And this table is also very important. Remember, the mild steel will also have very less amount of carbon, only 0.15 to 0.3%. remember this. So mild steel, we can call it as low carbon or soft steel. Low carbon or soft steel, or soft steel, ठीक है? So as it is low carbon, obviously it is what? It is ductile, it is malleable. And one more thing is, though it is ductile, malleable, the good thing is it is also having lot of strength. It is also having lot of strength. And remember this compositions if possible. So I told you mild steel is 0.15 to 0.3. If something has 0.3 to 0.8 percentage of carbon, then I will call it as medium carbon steel. And if the carbon content is more than 0.8, remember greater than 0.8, then I should call that steel as high carbon steel. High carbon steel. Okay, so I hope it is very clear. What is happening with respect to carbon? What is the problem with carbon? If the carbon is increasing, strength increases, hardness increases, but ductility is gone. Ductility is gone. So if I am using cast iron in place of steel without showing any deflection, my structure will collapse. It is brittle in nature, right? I hope you are getting the point. Okay, done. Right, this Bisner process कौन से साल में introduce हुआ था? 1856, still in use. Okay, so very powerful process. It gives very good amount of steel, right? So next, you might have heard these words very frequently whenever you are studying about certain metal. So it is produced by annealing process, normalizing process, ऐसे पढ़ा होगा. So what is this? Annealing means it is just a slow cooling of metal. Okay, you are heating it to a higher temperature. You are heating it, ठीक है? You are heating it, and then you are slow cooling it. You are cooling it very slowly. Then we'll be calling it as annealing process. Okay. But in normalizing, what is happening? You are heating it rapidly. Okay. First of all, you are heating it, and you are heating it to a very high temperature. We are heating it above the critical range, and then we are cooling it rapidly. And what we are doing, rapid cooling kar rahe hai. That is the only difference. So in annealing it is slow cooling, and in normalizing it is rapid cooling. It is rapid cooling. Okay, but we are not cooling at the same rate at which we are heating it. Okay, I hope it is very clear, right? So we are heating it very rapidly above its critical range, but we are cooling it to almost like room temperature, whatever, very rapidly. That process I will be calling it as normalizing. Done? Yaad rakhoge. And there is very frequently asked bit even in ESE. It could be asked for match the following: which of the steel is used for which purpose? Okay, remember this, very important. Ball bearings, whatever you are seeing, right, the ball bearings जो भी आप देखते हैं, it is generally made up of stainless steel or chrome steel. Very important bit. So the ball bearings, whatever we have, it is manufactured by stainless steel or chrome steel. And axials and springs, vehicles में हम use करते हैं ना, obviously it should take lot of load, right? Axials, the springs, they are generally manufactured by vanadium steel. Vanadium steel, very important bit. So springs are manufactured by, answer is vanadium steel. Axials are manufactured by vanadium steel. Ball bearings, chrome steel or stainless steel, right? So obviously if we are varying the composition of alloy, we get different property of steel, right? For example, you are adding chromium, तो आपको क्या मिल जाएगा? स्टेनलेस स्टील मिल जाएगा, राइट? स्टेनलेस स्टील मिल जाएगा. So stainless steel, it has good resistance power. Okay, it has acid and rust proof. Stainless steel, it doesn't rust easily. It is acid proof also, so it is very hard and tough. Whenever you are adding this chromium, it becomes resistant. It just become more resistant. That's it. Okay, so we have nickel steel also. We have inverse steel, again very famous. Inverse steel, you know this, right? What happens to it? It has very low coefficient of thermal expansion. That's why wherever there is a chance of increase in dimensions because of heating, basically what we do, for that avoiding of purpose, we will be going for inverse steel. Delicate instruments में हम basically inverse steel use करते हैं, for example watches etc. Next we have vanadium steel. Obviously high speed tools, automobile parts में हम vanadium steel use करते हैं. And next is manganese steel. This is also very important. इसमें क्या रहता है? High electrical resistance रहता है. It is hard, tough and strong. Okay, so manganese steel, manganese amount is 12 to 15%. In inward nickel percent कितना रहता है? 30 to 40%. Very important bit once again. In nickel, in inward steel, how much percentage of nickel is added? 30 to 40%. In stainless steel, 16% chromium is added. Now let us see aluminum. Similar to that of steel. Now let us see aluminum. Aluminum कौन से ore से basically produce करते हैं हम लोग? It is from bauxite. Bauxite formula Al2O3 2H2O. Basically the aluminum, whatever we are having right now, the metal, so it is basically from the ore of bauxite. Okay, there are some other ores also, you can remember the name: corundum, kaolin or chena clay or cryolite. Okay, so and what is the manufacturing process of aluminum? Similar to that of स्टील. बेसनेल प्रोसेस था वहां पे, यहाँ पे क्या है? बेयर्स प्रोसेस है. बेयर्स प्रोसेस है, ठीक है. सी वी कैन ऑल्सो एड अलॉयस of aluminum, right? We can also make alloys, right? So to make the alloys, what are the various elements we basically use? We can use copper, zinc, tin and lead. Okay, so remember the alloys, काफी important है. दो alloys frequently asked है of aluminum. First is duralumin. Duralumin, it is aluminum plus copper, okay, plus copper. We also have other things but in minute proportion. 0.6% iron, 3.3 to 0.6% silica, everything is less than 1%. But so basically remember, aluminum plus copper add करके हम duralumin बना लेते हैं. Duralumin is a very frequently asked bit, so it is aluminum, copper and other things. Next is magnesium. नाम ही कह रहा है, what is it? Aluminum plus magnesium. Okay, around 6% of magnesium add कर लेता है तो magnesium बन जाता है. See, these alloys are very frequently asked bits. Okay, these alloys are very frequently asked bits, so please do be careful. What are the frequently asked alloys in examination? It could be of any level, even CSE exam. Okay, civil services examination में frequently asked रहता है alloys के बारे में. So if a question comes, what is a solder? Okay, so soldering करते हैं ना electrical instruments में. So soldering is nothing but combination of lead and tin, and lead plus our tin in 1:2 proportion. ठीक है. Bronze medal देते हैं ना, bronze medal. What is bronze medal? Copper plus tin. copper plus tin. Okay, next brass के तो door के door openings everything fittings will be using, right? So brass is copper plus zinc. So remember this very important bit as solder, lead and tin, bronze, copper and tin, and brass, copper and zinc. I hope you will remember it. So two chapters are done in this module, and now let us see timber also. Timber भी हम इसी chapter में देख लेंगे. Just give me a second. Just give me a second. बच्चों प्रिपरेशन कैसे चल रहा है ESE का? I hope you are working hard, right? I hope you are on the right track. So let us continue with timber also. Now coming to classification of trees. First let us see the timber. Classification of trees. How to classify my trees? See, I can classify trees into two parts. One is endogenous, second one is exogenous. If you are seeing bamboo, bamboo में क्या रहेगा? If you are seeing a bamboo, it will be something like this, right? Inner part is hollow, outside will be having materials, fibrous materials. I hope you got it. So if something is growing inwards, if the tree is growing inwards, okay, if the tree is growing inwards, then we will be calling it as endogenous trees. But if you are seeing some other tree, for example mango tree, कोई भी tree झाड़ में घर पे आपने जो भी देखा है, mango tree is the heavy one. So basically if you are seeing, it will be growing outwards, okay, with respect to time its dimension will be keep on increasing, and what is it growing? It is growing outwards, right? That type of trees basically will be calling exogenous trees. So this endogenous trees के examples क्या है? Like bamboos हो गया, sugarcane हो गया, palm trees हो गए, etc. When it comes to exogenous trees, obviously this exogenous trees can be subdivided into two important groups. One is conifers and second one is deciduous. Conifers means it will be like cone, it will be like cone type, whereas deciduous will be having broad leaves. Each leaf कैसा रहेगा? काफी broad रहेगा. Okay, in conifers it will be like pines, it will be like pines like this, okay, like this. So I hope it is very clear, right? No, this is not, this is also actually deciduous tree. You might have seen, right? You might have seen there will be trees like this, right? Cone type बनते हैं basically. So they are like conifer trees, for example deodar, chair, fir, kale and pine trees. Okay, basically whatever wood you are getting from these conifers or evergreen trees, they are the soft wood. Okay, I hope it is very clear. So leaves are like needles. Next, coming to deciduous trees. In deciduous trees obviously you will be having very broad leaves. In conifers we had needle type leaves, काफी sharp रहते हैं. Ashoka plant, all these things. Okay, now coming to deciduous, you will be having broad leaves, and these are the trees which give hardwood and good for like furniture purpose, okay, construction purpose, wherever we will be using this deciduous trees only mostly. Okay, for example ash, beech, oak, sal, teak, sham, walnut, etc. And beech, this beech whatever we have, it is of very high importance in India. पुराने जमाने में पेपर इसी से बनता है. So you might have seen, right, the Sanskrit, whatever, there will be a papers on which it will be written in Sanskrit, right? They were made up of birch trees only. They were nothing but bark of birch trees. Previously they used to write on bark of birch trees only. Okay, so it has very high importance in Indian history. Coming to this bark, now let us see these properties. So these properties are very important. Please be careful because questions can arise from this topic. This whatever table you are seeing, very simple hai? It is just a comparison between softwood and hardwood. Just go with the name soft and hard. So color, if you are seeing, obviously softwood will have lighter color, hardwood will have darker color. Growth, obviously this will have faster, this will have slower. Weight, ये light रहेगा, ये heavier रहेगा. Density, obviously you can comment which will have more dense, softwood or hardwood. Hardwood will have high density, softwood will have low density. Annular ring क्या रहेगा? In your conifer trees, this evergreen trees, you will be having distinct annular rings. Okay, you know the annular rings, right? If you are cutting a tree, what you will be seeing from the top? You will be seeing annular rings like this, right? Clear annular rings. So in softwoods basically they are very distinct, whereas in hardwood they are indistinct. Okay, I hope it is very clear, right? Similarly heartwood, sapwood, what are these? I will explain you so that it will be convenient. Okay, first I will explain you what is heartwood, sapwood. Okay, and strength, obviously which has more strength? Hardwood will have more strength, whereas the softwoods, they are strong only along the grains, whereas my hardwood, they are along and across the grains they are strong only. Now coming to conversion. Conversion means cutting into the timber, logs, whatever. Cutting will be easy when it comes to softwood because they are soft in nature, whereas in hardwood it will be difficult, right? And resinous material means gum type material ज़्यादा रहेगा इस sapwood में, exist in pores of chair, fair, etc. Whereas in hardwood you won't be getting those resinous materials. I hope it is very clear, right? So what is this hardwood sapwood? Let me teach you this first structure of trees. Okay, so if you are cutting a tree, obviously you can see two things. One is macrostructure, second is microstructure. Microstructure means on microscopic level. Cellular structure, उसका cell, जो wood का cell size रहता है, if you are seeing that, you will be seeing this microstructure. Okay, but what you can see with your naked eye, that is called as macrostructure. ठीक है? So first this is the pith, the central part is pith. ठीक है? So around it, this annular rings, whatever we have, right, we call it as hardwood. These are basically having lot of strength. It has lot of strength. Then the annular rings which are far away, this far away ना, हम उसे कहते हैं sapwood. Okay, so the closer to pith, we are calling it as hardwood, and far away this annular rings, they are called as sapwood. Okay, with respect to time, ये जो क्या हो जाएगा, hardwood बनता रहेगा, and this whatever this sapwood के बाद ये layer बन रहा है ना, you can see this clear part after this sapwood, that is called as cambium layer. This cambium layer would be converting into sapwood. Okay, I hope you are getting the concept. So the closest part to the pith is hardwood. After this hardwood we will be having sapwood. Sapwood के बाद हमें cambium layer मिल जाएगा. Cambium layer के अंदर क्या रहेगा? Obviously sap रहेगा. This sap granular material रहेगा. This sap obviously over the time it will be converting into sapwood. Done? And my size will be keep on growing. Right, so this whatever cambium layer is there, it is in between sapwood and inner bark. After inner bark you will be having outer bark. Bark is only for protection, it is not for strength, it is just for protection of my timber. Okay, done. It is like outer skin which covers my wood. And next, one of the most important thing is medullary rays. What are these medullary rays? See, there will be some rays passing through the pith to the outside portion of my wood. That I am calling it as medullary rays. Done. So this is about macrostructure. So what is happening in this? Let us try to understand. If you are talking about softwood, the hardwood part cannot be distinguished, whereas in hardwood it can be distinguished. Coming to sapwood, obviously it cannot be distinguished, but here it can be distinguished. Okay, done. याद आ गया, समझने आ गया ना? So hardwood and softwood, it cannot be distinguished in softwood, whereas in hardwood we can clearly distinguish between our hardwood and sapwood. Done. Now we have other types of classifications also based on modulus of elasticity. ठीक है, based on modulus of elasticity, based on the stress strain curve. Okay, so modulus of elasticity slope के उसके slope के बराबर से we can classify it into three groups: group A, group B and group C. In group A we will be having this modulus of elasticity in bending greater than 12.5 kilonewton per mm square. Remember this bit. So group A कौन सा है? Greater than 12.5 kilonewton per mm square, whereas group B 9.8 to 12.5, 9.8 to 12.5, whereas group C it is 5.6 to 9.8, 5.6 to 9.8. Okay, now on the basis of positions we have different types of timber. One is standing timber. Standing timber means if we have live trees, still living, okay, still giving fruit, still giving flowers, okay, if we have this type of trees, then we'll be calling it as standing timber. We have not at all used it yet, so that is standing timber. And the trees which are cut, the trees which are felled, we will be calling it as rough timber. And what is this converted timber? See, the timber, first it is in the form of tree, right? Our tree, whatever we are cutting into logs, we are cutting into planks, right? This, if we are cutting it into logs and planks after conversion, what we are calling it as? We are calling it as converted timber. Done. So structure तो हमने देख लिया है, macro structure देख लिया. Now let us see the microstructure. If you want to see what is the wood looking like at this cellular size level, then each cell you will be having what? Each cell will be having cell wall. Obviously outside we are having cell wall. अंदर क्या रहेगा? We will be having membrane, protoplasm, sap and core. Okay, we will having protoplasm, sap and core. So this is what it consists of. And remember this, it will be having protein consisting of carbon, hydrogen, oxygen, nitrogen, sulfur. Okay, but 90% of the protoplasm whatever we have is nothing but water. Obviously common sense की बात है, most of the word protoplasm it will be nothing but it is made up of water. Okay, so core of cell differs from protoplasm merely by the presence of phosphorus and is generally oval. So there is only one difference between the protoplasm and core in the cell of my wood. So only difference is core में क्या रहता है, protoplasm plus phosphorus रहता है, plus phosphorus. Okay, and generally this whatever core we have it will be oval in shape. So this is what you can see when you are seeing with the help of microscope on my tree. Now you can ask sir what is the age of trees for felling? क्या 5 साल के झाड़ को आप कट कर दोगे, 10 साल के झाड़ को आप कट कर दोगे? No, for using it in construction purpose or any other purpose, basically the trees age for felling should be 50 to 100 years. Okay, if it is more than 100 years then it will be over mature, that means there could be decaying of wood undergoing in it. If it is under mature then sapwood ही ज्यादा रहेगा, strength ज्यादा नहीं आएगा. I told you heartwood is the main thing which is giving the strength, so sapwood ही ज्यादा रहेगा, strength उतना ज्यादा नहीं आएगा. Done. And you can ask me sir when at what time we have to cut the trees, can we cut all over the year? No, ऐसा नहीं होता है. If you have hilly areas, if you are living in hilly areas, generally mid summers में कर लोगे, because remaining seasons you will be having waterfall or cool winters. When it comes to plain areas, basically हम कब करते हैं, winters में करते हैं, because what will happen if you are cutting in summers, there will be excessive moisture lost. Okay, moisture lost अच्छा ही होता है, because moisture what is happening after cutting off my wood, if there is a moisture loss then weight will decrease and it will be easy to transport, it's good only. But यहाँ पे क्या होता है, uneven moisture loss होता है, because of this summer season there will be uneven moisture loss. So क्या हो जाएगा, properties मार खा जाएंगे wood के, ठीक है. So there will be splitting of wood possible because of it, therefore we will be avoiding the summers and doing it in winters. Okay, done, समझ में आ गया. What is the true specific gravity of wood? It is 1.54 and similar to that of concrete. It compression अच्छे से ले लेगा, similar to that of most of the material. Compression अच्छे से लेगा, tension थोड़ा कम लेगा. So tension is only off to 1/4 time of compressive strength of our timber, and remember that. And I told you in the cell walls as well as cell cavity, as I have told you, the protoplasm of my cell in wood is nothing but 90% of water, right? So we have water in cell walls as well as cell cavity. If this water present in cell cavity evaporates completely, ठीक है, water present in cell cavity, अंदर जो water है cell के अंदर, if it is evaporated completely, then I will tell fiber saturation point is obtained. ये fiber saturation point काफी important है, याद रख लो. water कहाँ पे रहेगा, both in cell cavity and cell walls. If water in cell cavity is evaporated completely, then we will be saying fiber saturation point is reached. Now comes characteristics of a good timber. See, very simple hai, no need to worry much, you can write on your own also. So you should have narrow annular rings, that means closer annular rings, that means it is more strength, it is more aged and it is more strength. Closer the rings, greater will be the strength. It should have compact modular rays. Medullary rays whatever we have, right, this medullary rays, it should be compact, it should not be very broad, it should not be like splitting the wood. Okay, I hope it is very clear. Obviously it should be in a dark color, uniform texture, and it should have a sweet smell and shining fresh surface. Okay, and it should be free from defects. And when struck, and when wood is struck with other wooden piece, obviously you should get some sonorous sound. You should have heavy weight and there should not be any wooliness present whenever you are cutting it. So these are some properties of good timber. Now let us see seasoning of timber. See, the moisture content of timbers is bad, because if you have more moisture content there is a more chance of fungus to be attacking it, right? So fungi can come and attack it if it is having lot of moisture. Okay, so possible fermentation is there, therefore what you have to do, you have to do seasoning. Seasoning means moisture content को reduce करना है, so we are heating it or drying it. Okay, so obviously what is the concept behind it, why we have to do it. See, whenever we are cutting the trees, obviously it has lot of water because water is there in cell walls as well as cell cavity. So the newly fallen trees, it has moisture up to 50%. इतना moisture है तो fungus attack कर देगा and मेरा wood खराब हो जाएगा. So what I have to do is I have to decrease this. So I have to decrease this to less than 10 to 12%. My aim is to decrease the moisture content from 50% to 10 to 12%. Okay. So why we are doing this seasoning? Obviously, whenever we are doing the seasoning, some of the water is lost. So as water weight is gone, now it is easy to transport, agreed or not? So we can transport more logs on same vehicle. So it reduces the weight. Not only that, it has lot of advantages like it reduces the shrinkage and warping after placement in structure, increases strength, durability and workability, reduces the tendency to split and decay, make it suitable for painting. All these additional advantages are there when it comes to seasoning of food. That's why seasoning is very important. We can do it naturally or artificially. Naturally में क्या करते हैं? Obviously we have air seasoning or water seasoning. In air seasoning what we do, we keep it in covered shed. There will be covered shed and we keep the wooden logs facing the wind direction. ठीक है? So we will be covering it in the wind. We will keep it open in crosswind direction in alternate layers so that the air will be circulating and it will be taking out my moisture. I hope it is very clear. So we'll be doing this air seasoning till the moisture content is reduced to 12 to 15%, and it is very suitable when it comes to large size timbers. Okay, if the tree size is very large, then air seasoning is the best. It is used very extensively in drying ties and the large size structural timbers. Now coming to water seasoning. What is this water seasoning? Sir, आपने कहा we have to reduce the water content, right? Moisture content, water content, whatever it is. यहाँ पे आप water seasoning कैसे कर रहे हो? See, what we are doing is, first of all, in the flowing river, we will keep these wooden logs, okay, and the larger size facing the direction, the upstream direction. So water whenever is coming, right, it will, what it does, it will clean the sap, it will clean the sugar and the gum, whatever is there, no, it will be leached out of my wood. Now whenever you are taking this wood out in the atmosphere, it very quickly gets start losing this water. Moisture content क्या होगा? Very quickly it drops. I hope it is very clear, right? But the unfortunate thing is this is a very quick process. पानी में रखो, निकालो, सुखाओ and जल्दी से moisture content कम हो जाएगा. But the strength will also be reduced when you are going for water seasoning. Done. There are some artificial seasoning also. For example, boiling. In boiling, what we do? We keep it in tub of water. We heat it to 3 to 4 hours. Okay, and then we are drying it naturally outside. If you are doing that, then it will be quickly drying and water will be gone. So it is very quick method. It is the quickest method of seasoning. But as we are heating it, we need certain energy to heat the water, right? So what is happening? Certain fuel is getting wasted. That means it is costly. Next is electrical seasoning. Obviously we will be passing currents through my timber and obviously the moisture content will be evaporating. Next is clean seasoning. Clean हमने यूज किया था सीमेंट मैन्युफैक्चरिंग में, क्लीन हमने यूज किया था ब्रिक मैन्युफैक्चरिंग में. यहाँ पे भी हम क्लीन यूज कर रहे हो, बट बी केयरफुल बेटा. वहां पे हमने हाई टेम्परेचर पे जलाया था, 900 डिग्रीज, 650 डिग्रीज, 1100 डिग्रीज. व्हेन इट कम्स टू ब्रिक वी हैव गॉन अप टू 1350 डिग्री सेंटीग्रेड आल्सो. बट इफ यू आर डूइंग इट टू वुड, व्हाट विल हैपन? वुड तो पूरा कार्बन से बनता है, राइट? पूरा जल जाएगा, राख बन जाएगा. वी आर हीटिंग इट जस्ट टू 35 to 40 डिग्री सेंटीग्रेड. Okay, so what we are doing it in this clean, this fully saturated air is forced to go into this wood at 35 to 40 degree centigrade. That's it. Okay, and water will be evaporated. And now coming to chemical seasoning, obviously we can immerse it in certain chemicals, okay, certain solution of salts, so that it increases the rate of evaporation and my moisture content is reduced. Next is conversion of timber. See, timber आपके मन मर्जी से कट नहीं कर सकते हो. We have to cut as per the specific shapes. What are the specific shapes we have? We have ordinary sawing, quarter sawing, tangential sawing, rift and radial sawing. See, this ordinary sawing will have minimum wastage. What we are doing? We are sawing ordinarily. ठीक है? Cuts generally are made tangent to annular rings. If you have annular ring, उसके टेंजेंट में आप कट कर दोगे, उसके टेंजेंट में कट कर दोगे. इफ यू हैव एनुलर रिंग, उसके टेंजेंट में आप कट कर दोगे लाइक दैट. सो इट इज मोस्ट इकोनॉमिकल एंड वेस्टेज इज मिनिमल बिकॉज ऑल द पार्ट्स you are getting a clear locks, right? You are getting clear locks and you will be using it. Done. So wastage is very minimum, but the section are liable to shrinkage. Next we have quarter sawing. We are cutting it as right angles. We are cutting this as right angles. You can see here, right? We are cutting it as right angles. This is called as quarter sawing. इसके properties इतने अच्छे नहीं है. Quarter sawing is done when annular rings are mostly indistinct. What we can go? We can go for quarter sawing, but properties are not that great. Properties are not that great. Section are liable to bend, in transverse direction. Next is tangential sawing. In tangential sewing, we cut along the tangent of annular ring. If you are taking this annular ring, I am cutting like this, I am cutting like this, I am cutting like this, I am cutting like this. I hope you are getting it right. So in tangential sewing, we are cutting along the tangent point of my annular ring, but the strength obtained here will be minimum. याद रख लो minimum strength किसमें मिलता है? Tangential sewing, not good. But coming to radial sewing, here we cut along medullary rays. Medullary rays आपको पता है ना? It goes from pith to outermost part. So we are cutting along this medullary rays in this radial sewing, and this gives maximum strength. Remember which gives maximum strength? Radial sewing, and minimum strength tangential sewing. Okay, minimum wastage, ordinary sewing. Three important bits from here. Okay, so now coming to defects in timber. See, now I will teach you defects due to conversion and defects due to fungi. I will teach you in next module. Okay, I will stop here. Defects due to conversion. Conversion yani we are converting my wood into this logs of timber, right? I am converting into logs, planks, whatever. So during this conversion, if you are not a professional, if you are doing as per your wish, then obviously there will be certain defects in my timber. What are these defects? Let us see. The first one is diagonal grain defect. So diagonal grain means whenever you are sawing it, carpenter आपने देखा होगा, he will be sawing the surface, right? So what is happening whenever you are doing or cutting improperly, then you will be getting diagonal grains. The grains which should be like this are now like this. They are now like this. You can see, right? We are getting diagonal grains. इससे क्या होता है? Strength कम जाता है. ठीक है? Strength कम जाता है. Next is torn grains. See, if some hammer is dropped on the surface of wood, obviously यहाँ इसे marks आ जाएंगे. We are calling it as torn grains. Okay? So obviously it will impact the look of the timber as well as strength भी थोड़ा mark आएगा. Next is chip marks. Same thing. Whenever you are cutting it but not properly, the carpenter shops में basically आपको ये बहुत दिखने को मिलेगा. If you are cutting it but not properly, then you will be seeing this type of chip marks. And next vein. See, whenever you are cutting the tree, sometimes what happens is the rounded portion, you can see this rounded portion, right? वो log के साथ मिलके आ जाएगा. So this type of defect we will be calling it as vein, right? The rounded edge is called as vein. Obviously it will affect my properties of wood. Done. So this is some defects due to conversion. In the next module I will continue with defects due to fungi. थोड़ा ही topic बचा है. After defects I will teach you some more things like preservation of timber, and this chapter would be done. Okay, preservation of timber and this chapter would be done, and we will also see some stones and bricks if possible in the next module and conclude. And today only SOM module will also be uploaded to you. Okay, SOM module will also be uploaded to the YouTube today only by evening. One module of SOM will also be uploaded, and the next module of this building materials will be uploaded tomorrow, and second module of SOM will also be uploaded tomorrow. Okay, as we are running short of time, I will make 2 modules every day. So till we come back to our normal speed. Okay, have a nice day. See you in next module.